তোমাদের কিছু ডাউট থাকলে এটা অন করে জিজ্ঞেস করবে, মানে একসাথে দুটো অন রাখলে ইয়ে হবে। ঠিক আছে, বোর্ডটা নিচ্ছে তো? ইলুমিনেশনসটা ঠিক আছে? ঠিক আছে না? Okay, so today's experiment will be the determination of the PV diagram, or to get the PV diagram. And the performance test of diesel engine. Okay, so here we have single cylinder 4-stroke diesel engine. Okay, now actually we will conduct this experiment in basically two parts. Okay, determination of the PV diagram, that will be done in the computerized single cylinder diesel engine. Okay, so that part we will do in one class, another class. So today we will actually conduct the performance test of diesel engine. Now performance test, what is performance test, we will see. Now first of all, let us see what is diesel engine. Diesel engine, you can understand that basically it is a compression ignition engine. Okay, so diesel engine means basically compression ignition engine. CI, or compression ignition. That means basically the source of ignition is compression. So what we actually do after the compression stroke, when the air is compressed, the temperature and pressure is very high. So temperature is high, above, it is above the self ignition temperature or auto ignition temperature of the fuel, particular fuel. After that, the diesel is injected into the cylinder, and then it gets favorable condition for auto ignition. So means the temperature is high, so that when you inject the fuel burn on its own. That is auto ignition or self ignition. Okay, so that is also called, so it is self ignition, right? The mechanism of ignition is self ignition. So that is actually therefore the source of ignition. So self ignition, self ignition or auto ignition. Okay, self ignition or auto ignition. Engine oil is obviously required, because without the engine oil, the friction will be too much and you cannot run the engine. After, say for example, few minutes only, or not even minutes, it will seize due to friction. There will be high temperature due to rubbing effect, and the engine cannot run anymore. Okay, so obviously engine oil is required all the time. Okay, but we are talking about the fuel that is used in the particular engine. So that is the diesel engine. Okay, so in the diesel engine we have basically the diesel as the fuel. As in case of petrol engine we have octane, right, or petrol. So in case of diesel engine, the fuel that we use is the diesel oil or diesel fuel. So here it is self ignition or auto ignition, that is the mechanism of ignition. You can say mechanism of ignition or the source of ignition, ignition source. Okay. So now next what we will see, the performance test. What is the meaning of that performance test? Now performance means, as loosely we understand, that means what? It is some ability, right? Performance means it is some kind of ability per parameter, right? So in performance there are many efficiency terms, as you can understand. So efficiencies, different efficiencies. What are the efficiency, different efficiency terms you have studied? Say for example mechanical efficiency, then you may have thermal efficiency, then you may have volumetric efficiency, okay. Different efficiency terms are there under the performance, okay. Now one thing that we have to understand is that there are many other terms related to performance. Say for example air fuel ratio, there will be one parameter. So air fuel ratio we will see. Mass ratio, gravimetric. Okay, mass ratio. Then you have fuel consumption. Fuel consumption. Fuel consumption, not only fuel consumption per unit power. We call fuel consumption per unit brake power. Okay, so you see that this is one term you are actually learning maybe the first time. Brake power, actually this is related to the power available at the shaft. So brake power means basically power available at the shaft of the engine. Shaft means the shaft from the engine that is coming, so that is the crankshaft or shaft. Huh? Hmm? Right, we get the power means torque means basically power divided by the speed. Okay, so this brake power, you see that brake means basically the to stop. When we apply brake to the say car or the bike, so what we do, we try to stop it. So brake means basically to stop. So this is an effort to stop the engine. Not we are stopping the engine here. We actually, when we apply the brake, in case of the car or bike, what we do basically, we try to apply the brake at the wheel. We do not stop the engine. The engine runs, but we disconnect the engine or disengage the engine from the wheel by using clutch, and then we apply brake. So brake is to stop the wheel, but here we are applying brake to stop the engine itself, but we do not stop it, we try to apply load by using brake. So that why actually we do that, we will explain. Okay, why we actually, what is the philosophy behind doing that. Brake power means, brake means to stop. You have to follow the spelling. B-R-E-A-K, brake means to break, to split, right? But this brake means to stop. We are applying brake to stop. Okay. Now, these are some of the parameters that we will basically study. What efficiency out of this we will study? We will study basically thermal efficiency. So that thermal efficiency we call brake thermal efficiency. That we will study brake thermal efficiency. We call it eta. Eta is the symbol for efficiency, and BTH, brake thermal. Okay, this is called the brake thermal efficiency. Now volumetric efficiency, we give it a name, eta volume. Okay, এটা ভলিউম। যদি মনে হয় যে ক্যামেরাটা ডাইরেক্ট নিতে পারছে না তাহলে মাঝখানে দিয়ে দিতে পারো। নিতে পারছে, দেখো তো পুরোটা আসছে, পুরো বোর্ডটা লেখা বোঝা যাচ্ছে না, সেটাই বলছি। তাহলে লেখাগুলো দাও, এমন একটা জায়গায় দাও যেন লেখাগুলো বোঝা যায়। সামনেটা দিয়ে দিতে পারো, যদি মনে হয় সামনেটা দেওয়ার আছে দিয়ে দিতে পারো। অ্যাঙ্গেলটা চেঞ্জ করতে লাগবে তো, ওই পিছনেটা বোধহয় তোমাকে করতে হবে, ওইটা না, এইটা 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 ঘুরিয়ে করতে হবে, এইটা এইটা। বোর্ডের লেখাটা আসছে তো পুরো পরিষ্কার? হ্যাঁ, দরকার হলে তোমরা এইভাবে চলে আসো না সামনেটা, তাহলেই তো হয়ে যাবে। এইভাবে রাখলে আসছে, এখানটা চলে আসবে, ঠিক আছে? আসছে তো? আসলে এগুলোকে একটু সরাতে হবে পরে, তা নাহলে আমাদের বোর্ডটা ঠিক পাবো না, ঠিক আছে? ক্লিয়ার? So CI, that is compression ignition engine. Self ignition is the ignition. Self ignition is the mechanism for the ignition. That is also the ignition source. That is compression or the compression work is the source of ignition. Okay. Next, we are discussing the performance test. So efficiency, different efficiency terms. Among these, we are actually considering the brake thermal efficiency as the quantity that we will calculate for this test. Then volumetric efficiency, that is eta volume. Air fuel ratio, gravimetric, the mass ratio, that is air, mass of air by mass of fuel. So we can write that this is equal to basically mass of air by mass of fuel, mass flow rate basically. So that is the rate of mass flow of air and rate of mass flow of fuel. Then fuel consumption per unit brake power, this quantity is having a special name, that is called BSFC, that is called brake specific fuel consumption. Okay, so that is called brake, so that fuel consumption, that is called brake specific fuel consumption. Okay, so that is brake specific fuel consumption. So what I have written, fuel consumption per unit brake power, that means mass flow rate of fuel divided by brake power, BP. So that is, এটা বোধহয় আসবে না, না বোর্ডে আসছে না, না হ্যাঁ আসছে, না আসছে, এটা আসছে। Okay, so BP, that is brake power. Now the quantity that we will study first is called brake power. That is BP. Okay, brake power. Okay, now there will be basically the philosophy of stopping, we will discuss that. Okay, so these are the quantities that we will basically study in this test. PV diagram we will draw in another experiment. There will be basically sensors, so by using the sensors we will measure the cylinder pressure and the cylinder crank angle. So pressure and volume, so volume will be related to the crank angle because this is a single degree of freedom system. So the change in angle is directly connected to the volume. or the length of movement of the piston, and since the area is constant, so length multiplied by the area will be volume. So from that we will get volume, and from the pressure sensor we will get the pressure data. So from that we will be able to draw the directly, we will get that PV diagram in the computer, okay, by the sensors data. So that we will do in another experiment. Here we are considering the performance test, because in that setup you don't have to calculate anything. There will be all the data, you will be just only giving the load, and all the calculations will be done in the software. So you will get the data ready. So to understand how the performance test is conducted, that is why we are conducting in the manual setup. Okay, clear up to this? Next what we will do is basically discuss what is the meaning of performance. Okay, next we will discuss the performance. No, by performance what we mean is basically the ability or the capacity, right? Kind of ability to take load basically. One thing that I want to give you an idea about performance. Say for example, if I want to understand your performance, then how can I understand? You may have some capacity, right? Maybe having some potential, but can you do this? That also I need to know, or that also I have to understand. So you have the potential, but say for example, say you are eating, right, some food. Now you have the potential of doing something, but after eating the food you are sleeping. Clear? So are you doing it? Are you doing means justice to the food that you have eaten? No. That means although you may have potential, but you are not doing it currently. So your performance is zero. That means you are not doing it. So performance means basically doing things, or you are continuously doing things. That gives you the performance. You may have potential, but potential is something else. You may have potential of doing anything. You may have potential of getting, say, Nobel, right? Nobel Prize. But are you doing? Are you doing to get that, or you may have potential to research, do research in NASA? But are you doing it? Are you doing something to achieve that? So that is related to performance. So potential is something else. You may have potential. Say it is said that human have infinite potential, but all persons are not doing infinite things. We are doing limited things. So whatever we are doing, that is related to our performance. Whatever is there, that is potential, right? But what we are currently doing, that is related to performance. So doing one thing, right? Whether you are doing it not, or a continuously doing. So doing performance is actually related to doing something continuously. Not that I am doing something now, say at this level, but fluctuating. It is fluctuating. So that is not performance. Performance means you're steadily doing something. That is related to performance. Performance and potential is different. I told. So you may have the potential of doing something, but you are doing it here now again, fluctuating. So performance should be at steady rate. So you should be doing something at, say, anything that you can do steadily. That is your performance. So that is the philosophy of performance. Doing things at steady rate, steady pace, right? So it should not fluctuate. That means we will consider the performance at a steady rate, right? For that machine, even for human being maybe, right? So performance means doing things or performing things steadily, doing or performing the job or the task. Right, the one. Steady. Steady means in mechanics we know steady means what? Constant with time, not varying with time. So steady means unchanging with time or constant with time. Speed, that is steady, right? Unchanging with time. Sorry. Unchanging, right? Thank you. Unchanging with time, right? So that means when you start do something, are you keeping at that rate, or your speed is decreasing, or your speed is increasing? But whether it is increasing or decreasing, at which rate it will become steady, that will give us the rate of performance. Okay, so that should be always at the steady rate. Steady rate means at constant speed, at same speed. So speed is one parameter for performance that we can understand, right? So speed is one performance. Speed, constant speed. Okay, one thing. Now therefore, say for example, load means what? Now one thing that we have to understand, that if I want to measure the performance, if I want to measure performance of any engine, say for example, I want to buy one engine. So I want to check what should be the power developed by this, right? Now, say for example, it starts developing power, at value. Power means what? Torque multiplied by speed, right? So now it is giving, say for example, 6 kilowatt, fluctuating, say again back to say 4 kilowatt, again back to say 3.5, 4, again coming to say 2. It is not steady. So which rate I should take? That means I have to take say the lower value, lowest value, so or whatever, at whatever speed it will become steady, that I have to take. So therefore, speed is very important. I have to know at which speed it can take the load, right? Say say for example, you are running. Now you are running at very high speed with no load. We consider that you have no load. You are running freely. Now I suddenly put a load on you. So for example, you were running at say this speed. It is very crucial to understand it properly, the performance. Now say this is time and this is load. Okay, I'm sorry, this is not load, okay, this is a speed. Okay, this is a speed. Now when there was no load, say it is a one load, when there was no load, you are running at this speed, right? You have some own body weight and you can carry that body weight at that speed. So when you actually are carrying your own weight, we sometimes call the engine is carrying its own weight. This flywheel, then you have the crankshaft, then engine, piston, right? It is having some load, which we call it is running at free load, no load condition. But it has some inertia, so it has to carry some inertia at that load. It is running at this speed, say. Okay, now I put on some load. Say you are running at that free condition. Now I put on some load. Clear? What will happen to you? From that high speed, it will become this. Clear? So say for example, you are running. You are running, and I put a load on you. Look, this is a load. Now your speed will decrease. Your speed will decrease. So from this it will become this. Right? Now see that the load, the suddenly it does not become this one. What happens? Rather it gradually decreases. It will not suddenly become from say 10 meter per second to say 3 meter per second, it will not suddenly become 0. Instantaneously it will not become 0. It will take some time to adjust. That load is put on you and you will adjust also, right? It will not suddenly become 10 to say 3. It will take some time, right? So that is a time. Now if I calculate the performance at this speed, it will be erroneous. If I calculate the performance at this speed in between, then it will not be correct. Even if I calculate the performance at this point, just when I have put the load, that will be also erroneous, because only that time I have just put the load, right? It will become some minimum, it will become some lower value, but it starts lowering here, and in between it is getting lower, decreasing. Clear? So at that point it will become the steady value. That means, what is the meaning? That means when I put a load on you, initially you are running at this speed, now you will run steadily at this speed. That means after adjustment you are comfortable at this speed. I have given a certain load on you, now you are comfortable at this speed. You are not comfortable at this speed or this speed, this speed. Still it was decreasing because your performance is not at that rate. Now, how you are performing basically? How you are performing? Because you have eaten something. Now you are burning your fuel inside, your food you are burning, right? And you are basically producing that energy which is consumed by the resistance. I have put some resistance on you. Now, therefore, this resistance means it is acting in the opposite direction, and your energy is trying to overcome that resistance. Clear? So you are burning energy, means you are getting by burning the fuel or the food, and you are producing that energy which is consumed by the resistance. That means your energy level is something and this resistance is something else. Now when it will become steady, when the resistance and your performance will become same, then only at this the speed will become constant. Because if I draw the free body diagram of this, say for example, if I draw the free body diagram simply, then you are producing some force by burning energy and your resistance is this. When these two become, say for example, there will be friction, etc., all these things, but just by this is resultant force generated by you and this is the resistance from the opposite direction. So when these two will be same, from Newton's second law, we know this is F1 and this is this is F2 and this is F1. When F1 and F2 will become same, your acceleration will become 0 and your speed will become constant from Newton's second law. F is equal to mass into acceleration. So this is force, this is actually summation of all forces, that means resultant. So this is basically, so the forward force is F1 and the backward force is F2. So m into acceleration. Now therefore this is 0 resultant because it is same, therefore it will become 0, right? 0 vector is equal, null vector is equal to mass into acceleration. Therefore acceleration is 0. Acceleration is null vector 0. That means your speed will become same, constant. So your speed will not change. So that is the idea behind performance test. That means when I put a load on you, at which speed you are comfortable to carry that load, that is giving your performance. In between, you have to understand that in between this is not your performance, because of load you are not capable of taking that comfortably, you are still getting exhausted. Now at this speed you will become comfortable. So that is the ability to, that means ability to do it consistently, steadily, that is performance. Okay, is it clear? So therefore this is for the engine also. That means when I apply load, it will become steady. Say initially at free load or no load, it was running at say some velocity at speed RPM, say 1500 RPM, right? 1500 RPM. After I apply load, it becomes, say for example, say 1400, say 60 or 65. So that means I have to allow this time immediately after applying the load, I will not calculate or I will not observe the readings. I will allow some time for the engine to become steady. Then when the engine speed will not fluctuate anymore, then only I will note the observation. That means the parameters. We will take several parameters. So we will note those values only when it is steady. So during this fluctuation, we will not measure or we will not observe or we will not note those values. Okay, is it clear? So why we are doing that? Okay, now you see performance. Therefore, one thing that I have given you, so related to the load. Okay, now another thing is that what is the philosophy of applying load? We want to measure the performance. So in relation to that, what is the philosophy of applying load or putting on load? Right, that we have to understand. That means why we are putting on the load to understand the performance. Clear? Say for example, I have given you a syllabus. I have given you a syllabus and I ask you to study. So all three. I have given a syllabus, same syllabus. I am asking you to study. So what you will do? You will go at the hostel and sleep. You will not study. You will study only when there is an examination. Right? That means examination is the load. So you will perform. So if an examination is there, that will force you to perform. Right? So that means when there is a load, by applying load only I can understand the performance. Otherwise, I have given you the syllabus. If I do not ask you anything, that means I do not take any examination, then I will not be able to understand your performance, whether you are studying or not. Say, answer, sir, I am studying. Say, all the three, say, for example, 3 engines are there, all 3 engines are running, right? Only running. But if I apply load, what will happen? I do not know. So I have to apply load to test that what happens. So that is the philosophy of load application for understanding the performance. That means to understand performance, I must apply load on you. That means I must give you some task and there will be some assessment. Right. So these are the assessment of the engine, that by applying load, you can understand the performance. Otherwise, I cannot understand. Engine is running. How can I understand whether it is performing or it is able to perform? Right. Whether it will after application of load, whether it will stay here or stay there, I do not know. So I will not be able to understand the performance without application. Only engine will not give you the performance. So to understand the performance, you have to apply load and you have to watch where they stay, where it results, where it comes. Clear? One thing. Another thing of applying load is that you see this one. You see, this is the resistance. That means if this resistance is, say for example, F2 and you are not producing F1, then what will happen? Your speed will become further less. Your speed will become further less, right? Isn't it? So that means whether I am able to carry that load, I have to produce that load. So whatever load I am applying, I have to produce that load. That means the philosophy is that if the speed becomes if the speed becomes constant, that means what? Whatever production is there is resistance same. Clear or not? The philosophy behind this speed, constant speed, is that whatever I am producing or the engine is producing and whatever be the resistance, they must be same. That means by applying the load, I understand what is the production by the engine. Otherwise, I will, by the blank, the cylinder is within a casing. How can I understand that how much it is producing? Or say, for example, I am running. How can I know that what energy he is producing? The 3 good figures, right? Bold means stout figures, they all are appearing to be very same, right? But how can I understand what is the internal strain? Only I apply load and ask you to run. Then what will happen? One will become slow, another will become little faster, another will become faster. Right? That is the idea that we will get. By applying load, I will understand what is the internal strength he has. Whether he is able to overcome that load. Again, not only just overcoming that load, at what speed. Whether he is running slowly, same load. You can run slowly, another can run little faster, another can run more faster, right? So that means both are important, taking load as well as at what speed I am running. Is it clear? So that means for performance both are important. The load carrying, the engine that carrying the load, that means the amount of load is important. Also at which speed it is able to carry the load, right? So that should be clear. That is the concept behind performance. So this is a steady. If I put further load, then it will again become steady at that value, but it will take some time for adjustment. Clear? So if I apply further load, again it will become steady, but it will take some time for adjustment. So if I just keep on applying different higher loads, it will become steady at different lower speeds. Okay, and the load multiplied by speed, we will get the basically power. So power means basically load multiplied by speed. Power means basically force multiplied by, that is, speed, or load multiplied by speed. You will get it because power means basically work by time. So power means basically F dot ds by dt. So this is what F dot ds in mechanics, force multiplied by that displacement, that is work divided by time. Power is equal to work divided by time. So this is basically force multiplied by dotted with velocity, that is the power. So both, that is load as well as that speed, both are important. So this is the dot product, right? Dot. So that means force component along the displacement, or displacement component along the force, because it is that is work means what? That means the movement of the point of application along the direction of application of the force. So that is the work. So that means work is equal to force multiplied by that displacement along the direction of the force. Okay, clear? Performance idea is clear. So why should we apply load, and why should we observe at constant speed? What is the idea of performance, right? Is this clear? Are this clear? So from this diagram you can understand that they should be same when the speed will become constant. Therefore I will be able to understand what is the energy produced by the engine by observing this, because I am selecting this value. This is the load I am applying. Therefore at the same speed this will become constant. This will become same as this. That means if I apply whatever be the load, if I apply load here, say, then that means if I apply a in between load, that means the speed will become somewhere here, right? Therefore it will become constant. That means engine will produce that energy to overcome that load at that speed. Engine will adjust itself so that it will produce, right na? মানে কি এটা ধরো, if I say if I ask তোমার একটা ছোট একটা বল নিয়ে দৌড়তে বলি, তোমার যে স্পিডে দৌড়বে, আর এটা যদি এত বড় একটা বল নিয়ে দৌড়তে বলি ভারী, your speed will become less. That means you are producing energy but you are not able to overcome that resistance, right? So that most of the power is overcoming in resistance, right? You are running, so for running you need kinetic energy, so you are producing that, but to overcome that energy, that you are exhausting some energy that you are producing, right? Clear? So that way you have to understand. So that means this, by selecting this or applying this load, I am able to understand. That is a wise thing that we do for performance test. That means by applying this, otherwise I cannot understand what is the energy that is produced by this or force that it can produce. So by applying this I can understand that they must be same, because the speed is constant, therefore they are same, and then I can calculate the power. Force multiplied by velocity, I can measure the velocity, I can measure the force, therefore I can get the power. That is the idea of performance test. Okay, clear? Next, what we will do, we will basically apply, pause करो तो, हाँ pause करो. Okay, now so for applying the load, now we will use a mechanical dynamometer, that is called dynamometer. Dynamometer. So this dynamometer that we are using is called rope brake dynamometer. Rope brake dynamometer. So here you see the rope brake. So actually brake, you understand, brake means to stop. Rope brake means here by using a rope, that you can see, that is the rope, this is the rope. Okay, so this is a rope and this is called the brake drum. This is called a brake drum. So when we apply load, actually what we do, basically by rotating the hand wheel, we adjust the length. That means there is a thread, you can see. So this is a nut here. So by rotating the hand wheel, this thread, that is the bolt part, will come up, and therefore this will be shortened, and therefore this will be tightened. Okay, so that way what will happen, there is a fixed one, so this length will decrease as this will come up. This total length is fixed. Say for example, this to this total length is fixed. Now as I rotate the wheel, this part will come up, this will remain here, only this part will come up, and therefore the length will be reduced. The length that will be remaining within this part will be reduced, therefore it will be shortened, it will be tightened on the, it will be actually gripping on the drum, brake drum. Okay, so that will basically try to resist, that will apply friction, so it having large friction on this rope. Okay, so that will actually apply the braking effect. Okay, that is called rope brake dynamometer. There are two dials, you can see, when we apply load. So there will be, now you see that one thing that we have to understand, that engine, in this case engine will run in the crankshaft will rotate in the clockwise direction from this side, clockwise direction. Okay, now therefore when we apply load, this part will try to oppose the load, or this, sorry, this part, this side will try to oppose the rotation, and this side will try to assist the rotation. We will see that in the diagram, because it is a rotating in this direction. Now if I apply load, it will try to oppose this, but since it is rotating in this direction, if I apply load, it will assist the rotation. So one will be the resistance and another will be a kind of assistance. So both way, therefore this, because this is resistance, so this side you have more load on compared to this side, because you have friction. So we have studied frictionless pulley, but here we have friction, so definitely this side will be more. The load that we will observe on this dial will be more compared to this. Okay, that part, that load is called W. In notation we will call it W, and this part we will call S. Okay, yeah. Now there will be a cooling system, because there will be large friction due to continuous rubbing effect. So there will be cooling arrangement for this, otherwise it will be heated. Okay. Now let us see. So it is called rope brake dynamometer. So this is the brake drum. Okay, brake drum. Now we have a rope here. Okay, so this there is a dial and there is another dial. Okay, so this is called the rope brake, sorry, drum, brake drum. This total is called the D, that is the rope brake, brake drum diameter. Now there will be a load on this that we will call W, and the force that we will be seeing here is called S. Now if we draw the free body diagram of this, okay, so what we will see basically, for torque on this, what will be the torque on this? If I try to understand the torque, I am not drawing the free body diagram because there will be some reactions here that we are not interested in, because the reaction will not give you any torque. So you can draw the free body diagram, but that reaction part will not give you any torque, because they are passing through the center and we are trying to understand the torque about the center, so that will basically produce nothing. So even if I draw the free body diagram, that you have to keep in mind that we are basically considering the torque, the reaction that is or the forces that are resulting in torques. Okay, so there will be some reaction here, there will be some reaction here, but they will not give you any torque. So for example, Rx, Ry, there will be some weight of that dynamometer, that is drum, that will be also passing through the center. So that is a weight, or mg of the mass of the drum and the acceleration due to gravity. Okay, but the thing that we are interested in is the this one. So this is W, okay, and this will be basically S, okay, this will be basically S. Yeah. Now what will be the torque or moment or sum of moment or the resultant moment of all forces about the center? What will that be? So moment, say center is say O, so moment of all forces in the z direction about point O, what is that? Moment of this minus moment of this, it is anti-clockwise, it is clockwise. So W multiplied by d by 2 minus S multiplied by d by 2, that is the torque or the moment of all forces, that means resultant moment. Okay, now therefore it will be W minus S into d by 2, W minus S into d by 2. Now one thing that we have to understand, W is actually measured in kgf. W is measured in kgf, so this is in kgf, this is also in kgf. Okay, what is the meaning of kgf? Basically, if you have one object of say 1 kg, the object is a 1 kg. Now what load it will apply, what force it will apply, that is called 1 kgf, 1 kg force. So if you have 1 kg mass, so the force applied by this is called 1 kg force. So what is that? So mass multiplied by g, mass multiplied by g. So the force applied by 1 kg mass, that is called 1 kg F. Okay, so what is that? Force is equal to mass into acceleration. So it is 1 kg multiplied by 9.81 meter per second square. So that is, sorry, there is meter, right? Mass means what? Unit is 1 kg. So what is that? It is 9.81 kg meter per second square means Newton. Kg meter per second square means Newton. So this is 9.81 newtons. Better it will be to write newtons, because N I will use for something else, RPM of the engine, that I will use N. So to avoid confusion, we are using newtons simply. So that means 1 kgf means 1 kg force means basically 9.81 newtons. Therefore W kgf means W into 9.81 newtons, right? Therefore W minus S kgf means simply W minus S 9.81 newtons. Okay, clear? Hello. Okay, so therefore I can write this one, that W, okay, one thing, a D, what is the unit of D? Meter, Newton meter हो जाएगा. So it will be basically W minus S multiplied by 9.81 newtons multiplied by D by 2. Okay, Newton multiplied by meter माने joule. Newton multiplied by meter माने joule, or you can write in small case joules. Okay, now joules, अच्छा এটা ভুলে লো, এটা ভুল হলো, এটা তো টর্ক আছে, নিউটন মিটার আছে, টর্কটাকে আমরা জুলস লিখবো না, এটা ভুল হলো, কারণ টর্ক ইজ এ ভেক্টর. We will not write joule, we will simply write newton meter. ওকে, এটা একটু টেকনিক্যাল ভুল হয়ে যাবে আমি যদি জুলস লিখি. যদি নিউটন মিটার মানে বেসিক্যালি জুলসই, কিন্তু টেকনিক্যালি টর্ককে জুলস লেখাটা ঠিক নয়, কারণ জুল ইজ এ ইউনিট অফ এনার্জি. হ্যাঁ, যে একটু ভুল বললাম তাই না? একটু দেখে নিই কি বলছি, এটা টর্ক বলছি তো তাই না? তাহলে এটা ডব্লিউ ইন্টু ডি বাই টু, এস ইন্টু ডি বাই টু, আর ডব্লিউ মানে ফোর্স ইন্টু মিটার, ফোর্স ইন্টু লেন্থ মানে টর্ক হচ্ছে, আবার ফোর্স ইন্টু লেন্থ মানে ওয়ার্ক. হ্যাঁ, এটা জুলই তো হবে, মানে নিউটন মিটারই হবে. আমি জুলস লিখছিলাম ভুল করে, নিউটন মিটার হবে, নিউটন মিটার লিখবো, এটা কিন্তু লিখবো না, জুলস লিখবো না, নিউটন মিটার লিখবো. ওকে, clear? Why is it clear? Because torque is a vector quantity, and joule is the unit for energy, so that is a scalar. So I will not use joule, I will simply use newton meter. Clear? এটা মুছে দিন. Okay, next, therefore this is the torque, or we write it as T, torque. Okay, now what is power? Brake power. So any power say torque multiplied by speed, so brake power it will be basically brake power. Brake power is equal to Bp is equal to torque multiplied by omega. Okay, torque multiplied by omega. What is torque? This one. Achha, what is omega? Omega, right, angular velocity. Angular velocity or angular, here we can write angular speed also. Okay, what is that? If n is the RPM, it is rotating with n. N RPM, angular speed N. So RPM means basically omega is equal to twice pi N by 60, isn't it? So N means one rotation, it will be twice pi radian per minute. So N means per minute. So twice pi N means total angular rotation in radian per minute divided by 60, total angular rotation per second. So omega means radian per second. Radian per second. Okay. So this is omega. Therefore we can write here T into omega. What is that? W minus S into 9.81 into D by 2 into twice pi N by 60. What is the unit? Brake power. What is the unit? Newton meter multiplied by radian per second. That is Newton meter per second. That is what? So that is Newton meter. Here it is radian per second. So Newton meter multiplied by radian per second. So that is Newton meter per second. Radian is basically the ratio. So it will be Newton meter per second. That is what? What? আমরা W এখানে আবার W লিখেছি, ওখানে আবার ওয়াট ক্যাপিটালে W লিখলে গোলমাল হয়ে যাবে। সেই জন্য আমরা এটাকে ছোট করে লিখব ওয়াট। ঠিক আছে? So that is what? Or watts you can write watts. Now if I divide this by 1000, we will get in kilowatt simply. So that is simply energy conversion. W minus S 9.81 D by 2, আচ্ছা 2 এটাকে কেটে দিতে পারি simply, এটাকে আর ক্যারি করব না, we can cancel this, therefore it will be D into pi n. So you can write pi dn by 60,000. What is the unit? Kilowatt. This is 1000. I have multiplied with 1000, therefore watt becomes kilowatt. So this is the brake power. Okay, this is the brake power. Now what is, so is it clear? How do I do? Apply the load. So the reading here is W, reading here is S, and therefore we can calculate the torque, and from that we can calculate the power, that is this. Okay. Next, what we do? We calculate the brake thermal efficiency. So brake thermal efficiency. Brake thermal efficiency. So eta BTH. Brake thermal efficiency. So brake power per unit power from the fuel. So that means this is brake power divided by the energy from the fuel. So you can write brake power by power from fuel. Okay, so what is that? Brake power divided by power from the fuel means the fuel is having chemical energy. So when we burn the chemical energy is converted to thermal energy, is liberated to thermal energy, because these are exothermic reactions. So chemical energy is converted to thermal energy in the combustion. So that power is called calorific value. That energy unit is called calorific value. Calorific value means by burning 1 unit of fuel, how much thermal energy we are getting. or the thermal energy liberated by the fuel. So that is CV, calorific value, multiplied by mass flow rate of fuel, because calorific value means it is giving us the energy from 1 unit of fuel. So multiplied by the total amount of fuel, we are getting the total power from the fuel. So this is called calorific value, CV. Calorific value. Okay. Now therefore we can calculate this. Okay, this is okay. Another thing. Okay. Next we will calculate the brake thermal efficiency. I'm sorry, the brake specific fuel consumption. Brake specific fuel consumption. So that is brake power divided by mass flow rate of fuel or fuel consumption, rate of fuel consumption. So that we can calculate BP. Okay, because we have calculated BP, we can calculate this, we can calculate this. Okay, you can see BP by m dot f, m dot, I'm sorry, এটা একটু ভুল লিখলাম, এটা হবে m dot f by BP. That is mass flow rate or consumption, fuel consumption per unit brake power. Okay, that we have to understand. Brake thermal efficiency, if the brake thermal efficiency, the performance, if the engine has more brake thermal efficiency, then it is a good engine. But what is about brake specific fuel consumption? You see that BP is here. That means this is mass flow rate of fuel divided by brake power. That means what? If the brake specific fuel consumption is more, that means it is consuming more fuel to produce same brake power. So that means if BSFC is more, that means the engine is a bad performer. That means it consumes more fuel, but it produces the same power. So for unit amount of power, it consumes more fuel. So BSFC more means consumes more fuel, so it is not a good one. Clear? So good engine means basically good performance means basically less BSFC. That we have to understand. Okay, so this is related to fuel economy. Okay, next, brake thermal efficiency, brake specific fuel consumption, brake power. Then we will calculate the air fuel ratio. Then we will calculate the air fuel ratio. Air fuel ratio. So this is called A by F ratio, or that is given by m dot F, m dot A, that is mass flow rate of air divided by mass flow rate of fuel. Okay, mass flow rate of air, how do I measure it? We actually apply one orifice here. We apply one orifice here. Okay, this is the orifice by which we can measure the discharge of air. So through this orifice air will pass and air will come through this pipe into the combustion chamber. So therefore whatever air is coming, that is coming through this only. Therefore if I want to measure the air flow rate, I will use this for the discharge calculation. Okay, as you have studied, for example, say electrical flow, right? So for electrical flow we use ammeter, right? So ammeter is connected in the series, right? That means whatever current will go, it will go through the ammeter. So we will measure the deflection and we will know the amount of electric that is current that is going through this. Similarly, for discharge calculation also, that discharge measuring device always you will see that will be connected in the series. We have studied in Venturi meter, so that is connected in the flow path in the series. So that orifice meter that is connected in series with the flow. So air will come from the atmosphere and it will go into the combustion chamber or cylinder, but it will go through the orifice meter. So that is in series. Okay. Now we know that how to calculate the discharge in the orifice. We will discuss that if I get time. Now you see that orifice has basically two ends. One is the upstream side, another is the downstream side here. Okay, now to measure the in the orifice, actually what we will do, how to calculate the discharge. We know the orifice area. Now we need to know what is the velocity of air that is passing through the orifice. So velocity multiplied by area will give us the flow rate. Okay, so that will give us the flow rate. Now, therefore, how to calculate the velocity in the orifice? Okay, so that is a question. So for that, what we do basically, we employ a manometer. Okay, now by using manometer, we can calculate the pressure difference. So the manometer, there are two legs of the manometer, and there will be a manometric fluid here. So when air will pass through the orifice, then there will be two different pressures at the upstream side and the downstream side. There will be two different pressures. Accordingly, there will be deflection here, right? So now by noting the differences in the manometric fluid or the heights of the manometric fluid, we can understand that that is due to pressure difference, right? Now pressure difference and the velocity difference or the velocity in the orifice, they are connected, because you know in the Bernoulli equation there is the that is flow energy, kinetic energy and potential energy. They are related. So total, that is mechanical energy, that is flow energy, kinetic energy and potential energy, sum of these terms are constant along the flow path if there is no, say, loss, right? Now therefore there will be a relation between pressure, kinetic energy, that is velocity, and potential energy. Now between these 2 points the potential energy is same, because potential energy depends on the height measured from the datum. So since they are at the same level, so potential energy are same. So what can I do? So according to that, if I draw that, okay, see that. So there is the orifice plate. There is going into this. We take the upstream side as say 1, and at the orifice somewhere here we apply that, so that is 2. Okay, now between 1 and 2, if I write the Bernoulli equation, it will be P1 by rho, rho of what? Rho of air plus V1 square by 2 plus GZ1 is equal to P1, P2 by 2, P2 by rho F, rho air প্লাস এটাকে মুছে দিই নাকি, এটা তো লাগছে না, হয়ে গেছে। P2 by rho air plus V2 square by 2 plus GZ2. Okay, now these two are basically same. One thing, another thing is Here the area is much more compared to this area. Therefore, velocity here will be much less compared to this. Because the flow rate is constant, that means discharge is constant. Therefore, the velocity here must be much less compared to this. Therefore, V1 is much less compared to V2. Therefore, V1 is almost 0, much less compared to V2, V1. I'm sorry, V2. V1 is much less compared to V2. Okay. So that is why we can neglect this. Therefore, we can write that V2 is equal to under root 2 A2 P1 minus P2 by rho air. Okay, this I can write. Next, acha. Therefore, if I want to calculate V2, I need to know what is P2, P1 minus P2. Therefore, this manometer is connected to this orifice meter is connected to a manometer. Okay, so can I erase this now? So this is connected to a manometer. Okay, now this is connected here and this is open to atmosphere, therefore this is also open to atmosphere. That means as if they are connected virtually, right? So when the flow occurs, there will be a depression in the manometric fluid. So according to you, what level or what leg should have higher level and what leg should have lower level? Flow is taking place in this direction. So pressure here will be more compared to pressure here. Therefore, pressure here will be more compared to pressure here. So accordingly, the level of the manometer will be higher here and lower here because there is a depression, right? So there will be basically a manometric depression. So that is called delta H. Okay, manometric depression. Okay, this is delta H. Therefore, what is the pressure here? The pressure here is same as pressure here. This is P1. And what is the pressure here? P2. So you see that this is the extra level of water. Therefore, the pressure here is also P1 because this is connected by the same fluid. So what is the pressure here? P1. P1. So P1 is equal to P2 plus the pressure due to this. So P1 is equal to P2 plus rho of what? Rho of here can manometric fluid ki ache water. So rho water G into delta H. Okay, now this delta H is actually in centimeter that you will measure. Therefore, we will convert that to meter. That will be delta H by 100. Okay, so it will be basically, therefore I can calculate what is P1 minus P2. You see our target is to calculate P1 minus P2. So it will be P1 minus P2 is equal to what? Rho W G delta H divided by 100. Okay, so I can put it here. So it will be 2 rho W by rho air into G 2 আছে rho W by rho air into G into delta H by 100. Okay, so what is that? That is meter per second. Okay, so that is velocity. Now, what is the flow rate? Q theoretical flow rate to the orifice is equal to V2 multiplied by the orifice diameter. I'm sorry, area of the orifice. So what is that? Area means pi d square by 4. So V2 into pi do square by 4, right? Now therefore this is the theoretical discharge. So what is the what is the actual discharge? Actual discharge will be theoretical discharge multiplied by the discharge coefficient. So actual discharge will be Q theoretical multiplied by CD, discharge coefficient. Okay, discharge coefficient is given. Okay, so from this we can calculate the air flow rate, and by multiplying the density of air we can get the mass flow rate of air. So mass flow rate of air can be determined. Now volume flow rate of fuel we will measure by measuring in the burette. এটা একটু ঘোরা। Here we will measure the fuel flow rate. Okay, so there will be a particular amount of fuel that will be flowing, and we will measure by stopwatch how much time it is taking for that fuel to be consumed. So from that we will get the fuel flow rate, we will know the density of fuel, and we will measure the density of air by noting the temperature, right? So we will measure the density of air. From that we will calculate the mass flow rate of air and mass flow rate of fuel. From that we will calculate the air fuel ratio. Okay, next one thing that remains, so I don't have much time for that. If I get time after the experiment I will discuss that. Okay, so there will be another thing, that is the volumetric efficiency. Now briefly I discuss what is volumetric efficiency. Since I can calculate what is the actual discharge, right, this is the flow rate of air. Now this is the theory, this is the actual flow rate of air. Actual flow rate of air means what? It is flowing through the orifice, means it is definitely going to the cylinder, because it is a steady flow system almost, although it is intermittent, but the RPM is so high that it can be considered as steady, right? So air is going through the orifice and definitely it is going to the cylinder. Therefore it is the it is the air that is consumed by the engine or used by the engine actually. But there is a concept of volumetric efficiency, that is what তোমরা পড়েছো volumetric efficiency in air compressor also, that is actually the actual volume flow rate through the engine divided by the maximum possible volume flow rate. That means, for example, if I breathe, that means say my lung capacity is say 1 liter for example, but I am taking or inhaling say only say 700 milliliter of air. That means my capacity is 700 divided by 1000, that means 70%. So my breathing efficiency or inhaling capacity is 70%. This is called volumetric efficiency in case of engine. So engine is inhaling, kind of it is sucking the air. So how much is the actual air that is inhaled compared to the maximum possible? Maximum possible means swept volume. So per unit cycle this is swept volume. So per unit time you have to calculate. So that we will show it later. Okay, so that can be shown. So we don't have much time. I have to pause করে রেখে দাও এখন, pause করে রেখে দাও, পরে আমরা আমি করবো আজকে আমি করবো আজকে?
না ওরা কম আছে তো,
আচ্ছা
একটু help করে দিতে হবে, কম তো হবে না। এটাতে ওয়াটার ফিলিং, ঠিক আছে?
সেই জলটা ইভাপোরেট করছে।
একটা ড্রামটাকে কুলিং করার জন্য একটা ওয়াটার সাপ্লাই করা হয় ড্রামের ভিতরে, যেটা একটা ডাক থাকে, ডাকটা অনেক জায়গায় বেরিয়ে যাচ্ছে, ঠিক আছে? রোটেশন আপনার মেশিনের জন্য জলটা বেরিয়ে যাচ্ছে ডাকটা, এটাই স্টিম জেনারেটর থাকে। ক্যালকুলেশন তিনটেই করতে হবে, ঠিক আছে? তুমি রিডিংটা একটু দেখাবে কেমন হলো। প্রথমটা কত ছিল, দাবিটা কত ছিল প্রথমটা?
এটা 14
আচ্ছা, আর এটা 24।
তাহলে 7.5 করলে
এই রিডিংটা একটু মনে হচ্ছে ডিস্টার্ব হয়েছে, এটা আরেকটু কম হওয়ার কথা। যাই হোক, মানে এটা আমরা কি পেয়েছি? টাইম। তাহলে এত টাইমে কত নেবে? 10 এনে নেবে। তাহলে 60 সেকেন্ডে কতটা? তাহলে পার মিনিট বেড়ে গেল। ওইটা কিন্তু বিএড এর লিখবে, এটা লিখে কিন্তু ক্যালকুলেশন করে পুরো নম্বর বের হবে, বুঝে গেল? এটা আমরা ডাইরেক্ট বিএডটা না বার করে আমরা এটা বের করে টাইমটা, এটা ফুয়েল কনজাম্পশনটা কম হলো, ইকোনমিক্যাল হলো। তাহলে এত টাইমে নেবেন 60 সেকেন্ডে কতটা, তাহলে বেরিয়ে যাবে, সেটাই বিএড এর জায়গায় হবে। এবং প্রতিটা আলাদা আলাদা ওয়ান সিরিয়াল নাম্বার করে আলাদা আলাদা লিখতে হবে।
ওখানে চলছে না, শেষ ওখানে শেষ।
ওখানে অন করে এরিয়া তো
ও কোনটা দিয়ে?
ওই ইয়ে করতে হয় মেটাল
আচ্ছা
লাগবে।